what happens with these genes is sometimes they carry what we call mutations. And these mutations result in, when the genes are ready to be expressed and manifested in your human body, they are in a way defective. Okay? And therefore, you have certain mechanisms in your body that are subsequently become defective. And those defective mechanisms or dysfunctional mechanisms lead to the manifestation of cancer. So that's the first really major cause of cancer, which is the DNA aspect. Tumors can grow anywhere. You've got one in your colon, maybe brain tumors. Of course, you have skin cancers, tumors in the skin. And that's essentially the way that these DNA mutations manifest and they cause cancer. It is important that people do their, cancer screenings. They visit their physicians, their practitioners, to make sure that there's no development of cancer. This is especially important if you start witnessing symptoms. If you, out of the blue, start witnessing, gastric issues, you should, visit your doctor and make sure, that it's not something that you have to worry about.
In a world where Africans have lost their roots, it has become of vital importance to document our ways. In an effort to reverse the brainwashing of the past, where we were made to believe our ways are demonic, we are pressed to create dignified and respectful platforms to unpack our spiritual ways. The views and opinions expressed in this episode are those of the guest and do not necessarily reflect the beliefs or position of this channel, its hosts, or affiliates. This podcast is a platform for open discussions and exploration of various perspectives, including controversial and unconventional ideas. We encourage viewers to think critically, do their own research, and form their own opinions. The content is for informational and entertainment purposes only and should not be taken as fact, advice, or an endorsement of any specific viewpoint. Viewers' discretion is advised. This episode is brought to you by the University of South Africa.
MOYA, light, MOYA, bright. Welcome to another episode of MOYA podcast. As we know, we are working with UNISA so that we can introduce you guys to some of the courses that they do at the University of South Africa so that you can understand. Also, I know a lot of you guys are very young, so trying to figure out which way to go. So we try to bring in the researchers, the teachers to come and give you the education that you're not getting at those schools. Kamalam Guntikimazwai, thank you so much for joining us. I've got Dr. Vani AKEEL, correct. Thank you so much for joining us. Obviously, you work at the University of South Africa.
Yes.
And today's conversation, we're going to speak about the body and the cells, and you're doing some work on cancer, right?
Yes, that's our main research focus on cancer.
Okay, so can you unpack it for us? Because I know that for long we've always relied on pharmaceuticals, but I believe you're trying to now create ways that we start creating vaccines and things right here. So let's start there.
Yes, hi. First off, good afternoon, Siki. Thank you so much for having me on this platform. So our lab is primarily focused on drug design, specifically with regards to cancer treatment. And so cancer is your stereotypical complex disease. And with those complexities, it's pretty much complex across the board. That's with the causes of cancer, that's with the manifestations of cancer, in other words, the symptoms that you find. As I'm sure you and a lot of the audience are familiar with, you get various different types of cancers. You get all the way from the top of the body to the bottom, you have cancers. So with that comes complications as well with treatment. And so our lab as a whole, are stimulating efforts in various avenues of research that are trying to target this demand for cancer treatment. Because again, it's a complex issue. We have treatment that works very reliably and very well, but the side effects are tremendous for some cancers. Other times the treatments are not universal. That is to say, they'd work for certain types of cancers, but not for others. And so that's our primary goal, which is to find novel treatment that's more versatile, that can work for various forms of cancer. Every day, every week, every month, there's a new development in this.
So what exactly is this Fly Lab? Can you unpack it more for us?
So I was introduced to the Fly Lab by the esteemed leader, Professor Monde Ntwasa, last year, September, when I joined UNISA. And he introduced me to the team, and I met these truly brilliant scientists. Their aim, their dedication is really truly unparalleled, and it's exactly what the type of caliber of individuals you would expect from a world-class institution like UNISA. So the history of the Fly Lab is actually very deep and rich. And let me just explain kind of the link between fly and cancer.
Please.
So the Fly Lab, currently we predominantly focused on cancer research, but the context and the history of the word fly comes from Professor Ntwasa. So when he started off the lab, he began investigating cancer, various aspects of cancer in flies. So there's a fly that's very commonly used in science, and it's a fruit fly called Drosophila. So that's the origin story of the word Fly Lab. And thereafter we started expanding into other avenues, from just flies. Prof. Ntwasa and his team, they grew, they developed, and now we use very advanced cell culture technologies where we use actual human cells. We use animal models as well as clinical trials, which we're doing at the moment, which is where you actually perform testing on human patients. So that's pretty much the background of the Fly Lab.
And then for us who don't quite understand what is cancer, because it's a world of its own.
Yes.
And how do we respond to it? What is the body doing when you have cancer? Like, can you unpack it, strip it down to us so that we walk away here being able to be professors?
Yes, absolutely. So when I started off, I said that cancer is your stereotypical complex disease. So let's start off with the causes of cancer. So like I mentioned, there are various causes of cancer. There's no single cause that works independently to manifest cancer in the cell. So at its core, cancer is a disease of the genome. So as you know, human beings have DNA within us, and that DNA essentially makes us what we are and makes us who we are. And you and I are different. We're both the human species, but our DNA distinguishes us. So those causes can be kind of grouped into certain major categories. So the first would be heredity. So what happens is, of course, you inherit genes from your parents, who inherited it from your grandparents, and up we go. So what happens with these genes is sometimes they carry what we call mutations. And these mutations result in, when the genes are ready to be expressed and manifested in your human body, they are in a way defective. Okay? And therefore you have certain mechanisms in your body that are subsequently become defective. And those defective mechanisms or dysfunctional mechanisms lead to the manifestation of cancer. So that's the first really major cause of cancer, which is the DNA aspect. Secondly, I'm sure you've heard the term carcinogen. So there are certain materials, there are certain foods that we can eat, exposure to certain chemicals which are considered carcinogenic. Cigarette smoke is a common one. And what these actually do is they go and they directly damage your DNA. And therefore, when that DNA becomes replicated, because our cells are constantly replicating, okay, we know if we get injured somewhere, it heals. When that DNA becomes replicated, that damage prevails in the let's say the daughter cells. So you have a mother cell,
Okay,
you know, it
yes.
splits up, you've got
Yes,
two cells.
yes.
And that damaged DNA stays and it travels down. And that leads to the mutation, and that leads to the dysfunction, and then so the cycle repeats. So that's basically pretty much the causes of cancer summarized in a nutshell. Then pretty much what people are familiar with are, you know, the symptoms of cancer. So we know people get really terribly sick. We know that people end up with certain tumors. So those are the main types of cancers. Your solid, what we call solid tumor cancers. And tumors can grow anywhere. You know, you've got one in your colon, maybe brain tumors. Of course, you have skin cancers, tumors in the skin. And that's essentially the way that these DNA mutations manifest and they cause cancer.
Sure. So from what you said just now, it means that cancer can be hereditary then. It can be a family sickness and there's nothing you can do about it. It's just in the family blood.
Absolutely. So cancer is a heredity, to a large extent, a hereditary disease. However, the body has ways of defending itself. So if you have a certain mutation in your gene that you've inherited, and in terms of other aspects of your life, you're not, or your cells are not undergoing such a great stress of DNA damage, like I mentioned to you, exposure to carcinogens, you can sort of, let's say, impede the onset of cancer, which is why generally cancers show up later on in life. We know very well that, of course, certain cancers are what we call childhood cancers, but most people, you know, they're diagnosed in their adulthood, and very often in their later adulthood. I must add that cancer is not, which I actually mentioned before, it's not only one factor acting independently. So yes, absolutely, there is a genetic component, but it's not only the genetic component acting independently. It's other factors as well, and it comes down to mainly those carcinogens. And actually, on the topic of that, so with these various factors, other things that can cause cancer would be certain viruses. So we know, for example, I'll just give you an example. HIV is a virus which interferes in some way with our DNA. We know that it integrates into our DNA, and that's why it's so difficult to fully cure HIV, right? In quite the same way, other viruses go and they cause, let's say they interfere with our DNA, and this causes dysfunction, and that causes those same mutations, and those mutations lead to the same cancers. So cervical cancer is a common one, which is particularly susceptible to manifesting in the event of viral infection. And the virus that's responsible for cervical cancer is HPV, human papilloma virus. So again, you see I'm kind of painting this picture of quite a complex landscape surrounding cancer.
So you even spoke about the symptoms. Would the symptoms only be tumors, or what would a person have to look out for to, you know?
So yes, usually the most, I would say the most prominent types of cancers are your solid tumor cancers. The other variant being your blood cancers. So these are cancers of your actually your blood cells. And they differ in various aspects. One way that they differ is, of course, blood flows throughout your body. So it's not localized to any particular organ. Whereas usually if you have a tumor, it's usually localized to a particular area.
Yeah.
So you have a tumor on your stomach, for example, with stomach cancers. You have a tumor on your brain with a brain cancer. Symptoms usually, because you know a tumor is not something that's going to show up immediately in the first few weeks or the first few months. It usually takes up to a year to show up. It is important that people do their, you know, cancer screenings. They visit their physicians, their practitioners, to make sure that there's no development of cancer. This is especially important if you start witnessing symptoms. You know, if you out of the blue start witnessing, you know, gastric issues, you should, you know, visit your doctor and make sure, you know, that it's not something that you have to worry about. Because like I said, usually once symptoms start to manifest, at that point it needs to be stopped as soon as possible. Because if you give cancer free rein, it sort of trickles down.
It multiplies.
Absolutely, absolutely. It quite literally multiplies. That's a great word that you use, a very accurate word. It multiplies. So that's the main issue with cancer.
How do we support people that are living with cancer?
So usually the way that it works in a clinical setting is that we distinguish between people who are what word can I use? Who are eligible, let's say, for treatment, which is to say that the treatment is going to work. However, unfortunately, the sad reality is, and this is especially true of our public hospitals, you have individuals who show up for a diagnosis and it turns out that the cancer is beyond treatment. And then that they sometimes will refer to it as terminal cancer, which is to say we just need to make sure that this person is kept comfortable, make sure that their nutrition is up, and we treat them. Usually they do treat them, but with no hope of eliminating the cancer, but rather just improving their quality of life. So treatment does have to be administered on a patient-to-patient basis, and that's how it's handled in a clinical setting. Because unfortunately for cancer, there's no one-size-fits-all scenario for treatment. So it has to be handled on a patient-by-patient basis. And in fact, if you wouldn't mind me expanding on
Please,
on a
you've
few
got all
things.
the time.
So even for the cancer itself, you can have two individuals, and the one individual has colorectal cancer, which is cancer of the colon, and the other individual also has colorectal cancer. But when you take a closer look, you might find certain differences in that dysfunction which I mentioned. And person A might be dysfunctional in certain aspects, whereas person B might be dysfunctional in other aspects. So with cancer, a lot of it is trial and error. You know, we treat the individual and we see, look, this works, so we can continue treatment. Whereas this other treatment, it works, but the side effects are so terrible that let's try something else. You know, of course, yes, there are commonalities. You know, if you talk about skin cancer, for example, across the board, yes, there are very many commonalities. But at the same time, there are differences, and that includes differences of race. So you have people of Caucasian descent who are affected by skin cancer in a certain way, and you know, a person from another race who is affected also skin cancer, but it's slightly different in some way. So cancer is it requires a constant effort. It never ends. It just goes, yeah.
We always hear of these stages. What do they mean?
So stages can refer to many things. Usually, again, in treatment settings, stages, in a nutshell, refers to how aggressive the cancer is. So what happens is, unfortunately, cancer is not kind to us. So once it forms somewhere, sometimes it's not as easy to just slice it off, which we call cancer resection. You know, so you if it's somewhere in the thoracic cavity, you open up, you remove a portion of the tumor, or you remove the entire tumor, and then you hope that, okay, we've eliminated the cancer. What happens with later stages? Of course, later stages is later time, meaning you've diagnosed later on.
Okay.
So what the cancer does is it undergoes a process called metastasis, and metastasis refers to when the cancer dislodges from a particular organ, and it travels via the bloodstream, hooks up somewhere else, and then it starts to fester and starts to proliferate there. So that's unfortunately the reality, which is that metastatic cancers are the most difficult to treat because you simply cannot just go under the knife, get rid of it, and you're done. You get rid of it, but you find out somewhere else there was a critical mass of cells now which are going to form a new tumor.
Yes.
And those are very common with your later stage cancers. Your stage 3 and 4 cancers are usually metastatic cancers. And then we rely heavily on radiotherapy, and we rely on chemotherapy to kill the cancer cells.
Let's go into that, into treatment.
Okay, so mainly you've got radiation therapy, which is where they use waves, radiation waves of a certain frequency and wavelength to eliminate the cancer cells. So this is, of course, this is a process that doesn't discriminate between healthy cells and cancer cells. So you can imagine now you're completely obliterating cells in a particular organ, a particular location, with these really, truly nasty radio waves. You need to eliminate the cancer cells, but at the same time, unfortunately, you have, casualties. You have healthy cells that you are eliminating. And most cancer treatment is, it doesn't discriminate between healthy cells and normal cells. So that's the first type of cancer, which is your radiation therapy. Then you have chemotherapeutics, and actually I should add that sometimes radiotherapy, there's various modes in which radiotherapy can work based on the type of treatment. So some of them might kill the cells right off. Secondly, some of them might send signals to the cell or damage the cells enough that the body sends a signal to say to the cell to say, look, you need to undergo programmed cell death. In other words, you need to get rid of yourself. And that's kind of another way in which the cells can be eliminated. Then second, you've got your chemotherapy. So chemotherapy is either administered orally with pills, or it's administered intravenously. And there are different types of chemicals. So the word chemo refers to a chemical, basically.
Okay.
Different types of chemicals are used for different types of cancers. So if you have got breast cancer, you use a certain type of treatment. If you have a certain type of breast cancer, you use a different type of cancer treatment. And then it's usually administered intravenously, and it usually goes, and that same mechanism that's dysfunctional, it tries to put the brakes on some dysfunctional mechanisms, to say just stop proliferating, stop creating more of yourselves, calm down a bit. And that's how it eventually acts as a treatment. And then depending on the cancer, it would need to be administered. Some people, they've got monthly treatments, twice monthly, that kind of thing, depending on the severity, depending on the type of cancer, and also depending on the individual. So, of course, if you've got an older individual, it would mean that you have certain complications to deal with. The person's getting older. Maybe younger people in their adulthood still, though. You can use something a little more aggressive. They'll be able to deal with it. And then, we know all too well the side effects of cancer. People start looking pale, a lot of weight loss. It's really devastating.
When you talk about chemo, when we see people on chemo, you can see that it takes a lot on the body. So what is people going on being on chemo? What are they going through?
I would imagine truly taxing and difficult times. it's like I mentioned, it's very devastating to the body.
Would that make you exhausted? What would the effects of chemo?
Exhaustion is a big one. Just general.
Is it painful? Do you know?
It's painful. It's painful.
So
depending
chemo
on
is painful.
it's painful. Yeah, it causes a lot of pain. We're talking even general body pain because of just the amount of trauma that your cells at the cellular level are going through. It's painful, particularly when the treatment needs to be aggressive. Because of course, there's no need to treat then if let's say, generally in a cancer clinical setting, we have it's very important that oncologists, doctors specializing in cancer focus on the quality of life of the patient. And how long is it going to take? It doesn't help if this individual is at a terminal stage of cancer and then you start aggressively treating, particularly if they're older. So in that case, actually, the doctor will usually sit with the panel of experts, and they will decide, again, on a patient-by-patient basis, they will decide, look, is it really worth it to administer such a treatment? Perhaps we should, tweak the dosages. Perhaps we can consider alternative treatments that are not as aggressive, but might still prolong, the lifetime of this individual. And unfortunately, like I mentioned, with the late diagnoses in our public hospitals, that's the reality of how things go. People are diagnosed so late because they don't have access to cancer screening facilities. They don't have access to those expert physicians, that are going to come in and
full
perform
tests.
perform proper diagnoses. That's why very often in magazines you'll see almost advertising for go and get your cancer screening check. Do your self-assessments for your cancers, your breast cancers. You can perform certain self-assessments. Of course, it's not as thorough as a clinician who will actually assess you, but it's something. You find a lump somewhere, it's not going to go away. Go have it checked up. That's very important.
Between the radiation and the chemo, are they both painful?
There are, nuances. There are certainly differences between them, but they both aggressive. They both can be aggressive methods of treatment. Even with the chemotherapies, they can be aggressive ways of treatment. So another big part of cancer research, in addition to it being this complex, multifaceted monster, another aspect is we've got to find treatment that discriminates, that can be selective, that can go target tumors, target your tumor cells, leave the healthy cells, leave them be. In an ideal world, that's what we would have. We'd just be able to target, and the person takes a pill every day, and within a couple of months, the cancer is completely eradicated.
So
we're not quite there yet.
What you are saying is that the treatment of cancer is actually still a work in progress.
Very much so, absolutely. It's still very much a work in progress. There are many. I'm really barely scratching the surface here with the nuances and the intricacies of cancer treatment, and how complex it is at the cellular level. Because, for lack of a better word, within your cell there's a war going on. In the cancer environment, and so we're really trying to assess that and trying to improve upon it.
So what are you guys working on that are going to develop and have new mechanisms to counter what cancer is doing?
So we have a few research efforts. The first is the drug design one. So we identified a particular molecule in the cancer cell that contributes to cancer development. And what they did was scientists took individuals at early stages of cancer versus individuals at later stages of cancer, the same type of cancer. And they found that in the individuals at the later stage of cancer, this particular molecule was found in large quantities. It was all over the place. Whereas in individuals, at early stages of cancer, it was kind of, a bit calm. And in healthy individuals, it was even less than that. So they therefore identified that this molecule was one of the major driving factors of cancer progression. So this molecule was really causing havoc in the cell. So we, as a lab, are trying to focus upon this particular molecule and find ways to target it. So when we say we target something, it means that it's going in the cell and it's going about its business and doing a lot of things that are promoting cancer. We need to go and stop it.
Yes.
So we need to go and somehow inhibit it, prevent it from being so overactive so that it can slow down the progression of cancer. So this particular molecule is what we're focusing on. And there's various aspects that go into that. So the first thing that we do is we perform what we call molecular modeling. So it is a molecule, and we basically model it, which is to say we try to figure out what it looks like, how it behaves, the different components of it, because basically a molecule, you can think of it on the scale of a large machine. It has many moving parts. It interacts in various ways. So that's principally where my expertise comes into play, which is really with modeling this molecule and trying to figure out how it behaves. And when you figure out how it behaves, you can figure out how to stop it and how to prevent it from promoting cancer. That's one of the major aspects when you first identify something that's contributing to cancer. And this particular protein, it's a molecule, was identified in many years ago. It was identified as early as 1995. So, and of course, that was when we identified it. Of course, it plays a major part in cancer pathophysiology. So that's one of the aspects of our lab. And then, in addition to that, we're also investigating a particular dysfunctional mechanism, which also likewise contributes or promotes cancer. And that mechanism is dysfunctional glucose metabolism, meaning how do we metabolize glucose? So human beings require food for energy. That's our main source of energy. We can't, like a plant, we can't get energy from the sun. So we need to eat to get energy. And it turns out that if you compare a cancer cell to a normal cell, the way that the cancer cell uses glucose, the way that it processes glucose, is quite different from a normal cell. And that aberrant or that dysfunctional way of processing glucose contributes tremendously to the development of a tumor.
Yo.
So, a tumor is really, I want to say it's an evil thing. It's truly evil. So what it does is it really creates for itself an environment where it can proliferate itself. So it aligns various factors for itself so that it can really grow and develop and maximize its growth until it eventually, the individual ends up passing away.
It's a parasite.
So you could say that, yes. So it's really, it absolutely, sucks up nutrients, sucks up energy. Tumors are great energy consumers.
What?
So with that comes the way that human beings process energy.
Yes.
So we are investigating this glucose metabolism aspect of cancer, and we're trying to, in the cancer cell, we're trying to prevent that from happening so that we can slow down the tumor growth, try to minimize tumor growth. That's ultimately That's one of the other major aspects that we're involved in our lab on the topic of cancer.
You know, when COVID struck, we realized that the need of creating our own medicine.
Yes.
Is the lab, when we speak about this and your research and all your developments, are we talking about a drug that's going to come out from us in South Africa, or?
Yes. Ultimately, that's what we're looking at. We are looking at going all the way from working with this particular molecule, this particular drug target, and taking it all the way to design and production of a drug. So when it comes to the drug design process, it is a very, very involved process. It requires, many different fields of expertise coming together. So it's not only your biochemist that's working alone. It's not only your chemical synthesis expert working alone. You really need to drive, these collaborative efforts. It really has to be a team effort if you want to bring a drug to, we call it bringing it to market. In other words, it's where you can, administer it to people. So I'll just kind of break down for you the basic principal steps of drug design. So once you've investigated your molecule and look, this molecule functions in this type of way, and I can inhibit it or I can impede it in this type of way, usually you identify what we call a small molecule. So the molecule which I spoke of is a protein. It's quite a large molecule. And you use a small molecule, which is usually a synthetic chemical. Though it doesn't have to be synthetic, it can be derived from a plant, for example. As we know, many plants are used as medicines.
Yes.
And this small molecule interferes with this guy who's causing havoc in the cell. So once we find that initial interaction, that's when the excitement starts. Everyone's scrambling. People are trying to find out, okay, what effect does it have? What kind of dosage do we need? How is the binding? Is it binding tightly, or is it, maybe it's binding and it's just flying off after a while? Then it's not really going to be, if we treat someone with it, it's just going to go straight through them. So then what we do is we perform a refinement process. So just like how you'd refine a piece of art or something, we take this small molecule and we refine it. So this occurs at the chemical level. So we take the molecule or the chemical and we change certain atom groups, certain atoms indeed, certain atom groups. We replace things here and there and we test again. Of course, all this we know kind of the basic fundamentals of what's likely to interact, what's likely to work better. Then from there we have a strong, what we call, you can call it an investigational drug. That means now it could be a drug, but it shows promise, but we need to now start testing it rigorously. And the drug testing process is rigorous. We begin by testing it usually just with the bare molecule, the bare target. So the same target that I told you about involved in cancer. We'll see in a test tube, okay, look, is it binding? How well is it binding? That kind of thing. But the test tube, we know, is not an accurate representation, or it's not any representation of a human body. So from there, we need to go to what we call cell culture. That's where we take cancer cells in a petri dish, and we test the drug on the cancer cells, and we investigate various factors, the tumor growth of these cancer cells. Do they die? Do they stay alive? And from there, we know it works in a cell. Then from there, we can move to more advanced models of testing. So usually then we move on to your in vivo testing, your animal testing with mice. In between though, nowadays actually, I wouldn't even say in between, it's almost a replacement for a mice. Well, I wouldn't say it's a replacement for a mouse study, but we get these very sophisticated cell culture techniques which actually resemble a 3D organ. And this is a very rapidly emerging technique in science, which is where we basically have an organ sitting on a table. Of course, it didn't come from any human being. It was just cells that assembled themselves into an organ.
Oh, what?
And we call it 3D cell culture. So that's very advanced, but we can test it in 3D cell culture as well. Because we really want, to cross all our T's and dot all our I's and make sure that this drug is going to work. And sometimes that might come after the animal testing, because of course that's human cells, whereas a mouse is a mammal, and it shares a lot of likeness to humans, but it's not exactly a human.
These things that you're talking about, these cells that build themselves, are you saying that if you took a cell from my lung, let's say, and put it in the right conditions, it's going to build up and become a lung?
So it's a little more involved than that. Unfortunately, it's not as easy as a cell that's able to self-regenerate. So it requires, yes, certain conditions, but there's some scientific wizardry involved there to get it into to resemble the tissue of an organ. And maybe in terms of scale and proportions, it might not look like a kidney lying on the table, but indeed the tissue, if you do a cross section, it will resemble kidney.
So interesting.
The tissue of kidneys, yeah. So again, this is a very sort of rapidly emerging method of testing.
Yeah.
And as you can imagine, it's quite expensive, and it requires, a lot of resources. You need a lot of money, firstly, and of course you need to test your drug before that, because you don't want to waste the effort, on that. Then from there, we usually end up with clinical trials, and your clinical trial is where you're testing it in a clinical setting with humans. So what exactly are we looking to assess? Firstly, we're looking to see, is the drug working? Okay. Secondly, we're assessing the safety and the tolerability of the drug. So it's not good enough for a drug to work, yet it causes...
Yes, like chemo.
Like chemo, exactly. And that's actually quite bizarre when you consider that the drugs used for chemo are the ones that passed testing. So that shows you, that basically actually is a good testament to really illustrate how low the drug success rate is. It's truly very low. It's something like, I think, around 1 in 10 experimental drugs that actually succeed. I mean, less than 10% success rate. I think it might even be lower than that. So there's a lot of rigorous testing that needs to go, and it's not just testing with regards to one aspect. We really need to consider various aspects, because you don't want a case where now the drug is released and then 5 years later people are starting to identify certain side effects and they pull it off the market. I'm not sure if you aware or familiar. That's happened a few times with certain drugs that were released, that were in the market for a really long time, quite well-established drugs, and thereafter they were pulled off the market because they identified certain links between, illnesses and sicknesses 10 years down the line. So that's why drug testing is very, very stringent, and in fact it's split into phases. So you've got your phase 1, phase 2, phase 3, and we really need to make sure that everything's done to the T.
And then, Doc, for the last question, obviously there's some young people who have watched this and might be inspired, young doctors. So what courses are at UNISA? Which department do they go to? What steps should they take so that they can grow up and be like you?
So we are in the College of Agriculture and Environmental Science, our wonderful dean here. Yes, UNISA offers various courses in the biological science, which is where cancer research sort of resides. And I think what's important for individuals is that if you have a passion for this, if you have a passion for the sciences, if you have a passion for a passion and a curiosity for things, for medicines, how things work in a biological setting, then yes, absolutely, UNISA has courses in the biological sciences, and this is not only with regards to the work that we do in our college. We have a variety of courses that are even adjacent to biotechnology or drug design, which we do. And you can still be involved in cancer drug design, for example. Like I mentioned earlier, it requires this collaborative, multidisciplinary approach. So if you have a passion for science, you have a curiosity, you're gonna fit somewhere in there, in the scheme of things, and I'm sure you can do wonderful work. I'm sure that everyone has something to offer, and everyone deserves, to be heard when they're speaking about these things.
Thank you so much for your time, Dr. Vali. That was so insightful. Thank you. Umoya ulight, umoya ubright, as we learn to take care of each other, and please especially exercise some compassion for people who are going through chemo. As we heard, it's actually quite a painful experience for them. So let's take care of everybody in our families and in our communities that are battling with this disease. See you again next time.
Who are you when all you were has been diluted by lies and white lines cancelling out all that which has been written of your history? Why do you look at yourself as a mystery? Doesn't the sun shine because you open your eyes? Doesn't the moon stay situated within the same stars your DNA sparkles off? Your spirit knows that surely corner into it off. Buza umoya so you may return to being well off. Because spiritually you are rich, yet your ancestors cry because you are out of reach. But yours is to command all elements while God takes inspiration from the very mirror she looked at to become. Remember who you are and never finish just when they think that with you they are done.